A very good morning to all. We have the dignitaries from the industry and very eminent speakers with me. So, first of all, let me thank IPTA to give me this opportunity to chair this session. And today, the session is on integration of systems to enhance business benefits. We have been talking about integration, modernization, automation, digitalization since yesterday. And a lot has been discussed. But when I was looking into the IPTA journal, and I got the copy and I started reading it, so I'm really impressed with Pawanji's comments. Integration of cutting-edge technology is not an option, but a necessity for sustainable growth. Really, sir, this is the time when we are looking for this type of achievements in our cutting-edge technologies, and we are witnessing it. Moreover, Mr. Krishnal also, he has given a remark, shifting gear from managing to controlling. Now, we have to control everything which has to be. And what exactly is pointed out, diagnose and drive digitally. So, really very encouraging to look at the journal. And we have seen industry is transforming. We all have witnessed yesterday. And today also we have some very eminent speakers with us. One is Mr. DeCosta will be talking about the technology development. And we have 3 case studies from the paper industry, what they have done. Before starting and coming to the point and inviting our speakers, I would just like to give an overview. What exactly we mean by system integration is basically in this particular session, it is a very wide subject, system integration. It involves everything like ERP, our customer relation management, even e-commerce, supply chains, and a lot of other things. But what we are going to discuss in this particular session is the integrated control systems, ICS integration. So they will, this is one part where we can see that we are trying to integrate our processes, our operations, and this is the first initial part where industry is trying to adopt digitalization or automation. And the second step after this will be the overall integration when we go to the enterprise resource planning and customer relationship management. So that will be the second part, a wider perspective of the digitalization. So with these comments, we have the opportunity to have with us 4 eminent speakers, and I would like to invite them. First presentation is from Haver, Mr. Dr. DeCosta. He will be talking about transformative impact of AI-integrated filtrate turbidity testing in paper and pulp and paper manufacturing. A very important subject, Dr. DeCosta, please, because the ticking, she is starting the clock. So we'll have 15 minutes presentation from Dr. DeCosta, and then we'll have the question and answer after all the presentations have been made. Thank you, Dr. DeCosta.
So this particular topic, what we would be looking at, the AI part of how you bring AI to an industry. So I've seen that we have talked a lot about AI. The AI word has been thrown around a lot. So this particular presentation, what I thought was we have split it into 2 different sections. So one, gives you a very background check on what AI is. A very basic level check on, okay, this is what AI can do. This is the capability. This is where we are. And then we'll look at how do we bring in this AI, even in a very small, increment to the industrial process that we already have. So to start with, let's see where AI is right now, right? So if you take any image generative AI and give it a keyword, it'll give you pictures, right? So this, when you type in paper making, just the word paper making, this image is thrown out. This is Meta AI doing its job. When you do modern paper making, it generates another image. When you do industrial paper making, it gives you the third image. So this is where we are with AI. This is the power of AI we have. It can generate, and these images, let me tell you, these are not pictures that exist. These were created when I typed in the keywords. This is new, this is unique. It has never been, copied from anywhere. But what the AI did is it looked at a lot of images, converted that into numbers. From those numbers, it matched with the keyword, and then it recreated an image, which is an entirely new image. So what's been happening is back in the 1950s, even more, before that, the Turing engine when it came. So what they were trying to do is to mimic the human brain, right? So that's what the entire concept is about AI. And then we move to the next stage where we call it machine learning. So what we wanted the machine to do was to learn what we already know. So just like we learn, we wanted the machine to do the learning. So what you do with this, you feed in a lot of data, all the data. It could be an image, it could be a video, it could be anything. Everything is converted in numbers. So AI is a number game. It converts everything to a number, a mathematical model. That's how it does, the prediction. That's how it builds, that's how it controls a system. So from that machine learning model, we move to deep learning. Now, this is where things gets really interesting, because when you reach deep learning, that is where it starts mimicking your brain. There are neural networks. So the entire architecture here is of your brain. Neurons connecting to another neurons. Exactly like that, they want to build a system which can do exactly this. So as I said, AI, we have seen what it can do. It's a number game, right? Now we are going to see what it can do in an industry, right? Now bringing AI to an industry. So AI can be used to do multiple things, like make music, make pictures, as I showed you. But when it comes to the industry, now here, let's see what we have. Let me get a pointer. Yeah. Okay. So it starts with data. The first section you see is a data stack. It could be the entire industrial, if you have a process, the entire process parameters can be fed in. So that's where it starts. Next comes the data cleansing. Now this is the most important and critical section of an AI system. When it does data cleansing. So you can feed in whatever you want, right? The problem is if junk goes in, junk comes out, right? So here, this is where this is where the human intervention comes in. This is where you tell the AI, hey, see, this is good, this is bad, okay? And this is the data we need, this is the data we don't want to look at. So AI learns from that, okay. And there are multiple ways of training a model: supervised, unsupervised, semi-supervised. So these are terms thrown around. It generally means that, hey, see, this is what we need, this is what I don't need. Can you learn from that? It learns. So it kind of keeps building mathematical models on that. It kind of learns from it, and then we move to the next stage. So I've told you machine learning, now it's building a model. So now you have given a data, now it had made sense with the numbers, now you have all the numbers kept in. Now what? The next stage is it has to create a model. It has to create a model that can predict a number. So here we say that, this is where, as I said, when I punched in paper making, it generated a picture, right? So this is where when an input comes in, it goes back and looks at the model and says that, hey, what's the image that I can throw at, right? Then it gives you a result. Now in industry, this result translates to a control signal. It could be, controlling a pump. It could be getting something switched on, switched off, the RPM of something. So it could be, it directly translates to an actionable point. Now, things doesn't end here. Now, that's the interesting part. When a DCS system, right, when a DCS system does a learning, what happens with that is, it stops at that control, it does take a feedback, right? Now the feedback loop in a DCS system is just to ensure that it's within the set point, right? Nothing else. It cannot do anything else. It just does that. It looks at the number, it says that, yeah, it's near to this, that's it. But when you put AI in this, the feedback that comes in, there looks at the feedback and it's like, see, there is an anomaly, right? Okay, there's a shift in this number. Where did this shift come from? Then it goes back and checks and sees, oh, the pH is different. They used a different chemical there. The pH got different. That's why this process, threw a different number. Now, this learning is what the AI, the power of AI really comes to. And this is what, we'll be also looking into in further the case study in our thing. So here, as I've mentioned, the last two parts, the continuous learning and scalability, this is where it has an edge over the present DCS system, the most advanced DCS system, even if you look at it. Now, let's look at, what we did, right? So, of course, we have an AI engine and we have some process. So the idea was, for this particular case study, what we thought was, let's take something that's very critical for the paper industry, okay? So charge demand was our candidate. And then we were like, okay, now we have charge demand. How do we measure it right now, right? So we have, usually, in labs, we have benchtop machines, which can do charge analysis. So that's what we have. And there are systems which can do online charge monitoring. It keeps on taking samples, so that's also there. But the most common equipment we saw was the benchtop one. Now with that, what we observed was their sampling is done twice in a day, or maybe even some cases once in a day, right? Now that's one data point that you're getting. And now you have to take the decision based on that data point, one data point, let's say one data point. And from this one data point, you take a decision. Till the time you don't check the charge again, okay, you don't know what the system is doing, right? You're in the blank. So what we thought was, let's see if we can correlate with any other parameter, like any other process parameter or any other parameter that is easily measurable, okay? And then, make a correlation. So what we did was, we went here, we took filtrate turbidity as this parameter, okay? So you have filtrate turbidity on one side, you have charge demand on this side, and the idea was like, okay, let's see if we can come up with a correlation and build a model. Now this particular part, the major challenge with this, I'll be coming to that, is, how do you continuously measure filtrate turbidity? So that's one challenge, and why that is important. The continuous measurement, which we get consistently and reproducibly. And the second part is, can this be done by a human? Can somebody, sit and make this correlation? So the answer is a simple no. Why? Because the data involved in this is such large a data that, if you use, let's say Excel or any data analytical tool, Excel I was just giving it as an example, you will fail at that, building the basic correlation. So what we did was go ahead and, put it at a customer site to see whether the actual data that comes in the plant can be taken and correlated with a filtrate turbidity system. Now again, as I said, why didn't we do this before? Filtrate turbidity has been there. Charge demand has been there. Somebody would have, obviously thought about there is a correlation because there are particles, turbidity, there is a correlation, coagulant if it's present. So somebody would have definitely thought about it, right? But the challenge lies in this case. When you measure something manually, you have to go through all this 5 problems when you are measuring something manually. Now that's where we found out that, see, just having an AI engine, a powerful AI engine, a powerful mathematical model, something that can predict the system parameters, it's not enough, right? So this is where I think the threshold, the barrier for AI to penetrate any industrial process that's been established, let's say, for the last 50, 60 years. So the barrier comes exactly at that point where these many problems are already existing. So for what we did was, we definitely have an AI engine which can do all these things, but so it does automatic sampling, continuous measurement. Now for an AI, the most critical part is the data that's fed in. So that's where we thought of, okay, we have the engine, we have the model, let's make something to do the automated sampling and continuous measurement. So that's where we created a system which keeps on taking a sample and does this in cycles of 10 minutes, 12 minutes. Every 10 or 12 minutes, you will get one filtrate turbidity value. And then this system has been created in such a way that it goes in tandem with an AI engine, because you don't need a lot of maintenance for this. This does all the washing cycle, this does the sampling, this does the dilution, this does the filtering. The filter that's used is an Sess filter, so you don't have to worry about that. So once you establish a correlation with whatever is the existing protocol in the mill for the filtrate turbidity testing, once you establish that with this, it starts giving you data. Now, from that data, what we do is feed that into the system. So the continuous and reproducible filtrate turbidity data, which is very important, it's fed in, checked for a trend, trend analysis with charge demand. From there, you move on to the machine learning model. So here is what you say that, hey, look at all the parameters and tell me whether there is a trend, whether there is a correlation, right? That's the first thing. Once you establish a correlation, what we are trying to do is we are going to jump from filtrate turbidity all the way to chemical dosing. So you're going to cut that charge demand that you do, at 8 hours or 10 hours, you're going to cut it short. Once you establish the trend, you can make the link from filtrate turbidity to the chemical dosing. Now, this is not possible by a human sitting there. Now, this is where the AI comes in. This is where the AI learns from all the data and takes a decision. The biggest advantage it has is historical data. So if there is a lot of data that's already fed in, it looks at all the parameters and it decides what is the right dosage. Now, historical data is something, that gives AI much more power. The second biggest power comes from continuous learning. So AI keeps on learning whenever it's taking a decision. So it'll remember the decision that is taken. It'll check whether it was the right decision. It'll see if it can make it better. And that's how AI, scores over any system. So when you look at it, this is, we took 2 grades, and we were looking at the filtrate turbidity, and we were looking at the charge demand, and anything above 70% correlation. So this was a very simple linear regression that we did. So anything that has a 70% correlation was selected, and then we did a k-means clustering. So k-means clustering is, in very simple terms, you take a bunch of numbers, and you see if this bunch of numbers can be clustered together, right? So, or even simple, you look at apples, oranges, and grapes, and you see, okay, can I cluster apples in one group? Can I cluster oranges in one group? And can I cluster grapes? So this is what we do with clustering. It's a way that AI can, compartmentalize data. It is a way that AI can categorize some data. So when a new number comes in, let's say when a new filtrate turbidity value comes in, and let's say it's for grade B, the green one you're seeing, it knows that it can choose from any of those dosing values, right? Now what it does is, now here's the next level of the trick the AI does. It doesn't go for the highest dosing, because if you want to save chemicals, and if you want to make sure that the performance is at the max, it won't do the highest dosing. It will select something that's a balance, a trade-off between the best dosing and at the same time the best input that can be given to the system. Now from there, we move to the advantage that we see. So what we could do is we could reduce the charge demand, the spread of charge demand. We could control that because we are doing it continuously, every 10 minutes versus every 8 hours. To conclude, these were the advantages that we saw, and directly going to the ROI part. So, annually 75 lakhs is what, the possible saving that we could calculate in whatever time we were running the system. So this is the direct, so you have a concept, how you directly convert the concept to to money. That's right here. To summarize, so turbidity, starting with turbidity measurement being used as a proxy. So that's one thing, right? The second would be how an automated system combined with an AI engine could cross the threshold and reach an actual industrial case. And the last being how we used dosage control, how the dosage control was achieved just by FTT and not by actually looking at charge control each time. So with that, I conclude the presentation. Thank you.
Thank you, Dr. DeCosta. A very good presentation. We will have the question and answer after the. So very good example of machine learning and artificial intelligence. This is the integration of a sensor. Nephrometers generally are used for turbidity measurements, and filtration unit before the sensor, then analyzing the data through machine learning and artificial intelligence. Very good example. And the best part is it can lead to significant saving in the chemicals which we use in our paper making. So thank you very much, Dr. DeCosta.